Alright, welcome. So today we're going to have a little bit of a basic introduction to organic chemistry. So let's get right into it. The first thing that you need to know about organic chemistry, or how we'd want to start, is you need to know what a hydrocarbon is. And you need to know this for your theory exam as well. They might ask you to define a hydrocarbon. And a hydrocarbon, you can deduce from the name itself, is a compound that contains hydrogen and carbon only. It's very important for you guys to write only, because if you don't write that, you will not gain the mark for this definition. Because if the compound has any other element, such as oxygen, then it's no longer a hydrocarbon. A hydrocarbon is simply a compound that contains hydrogen and compound and nothing else. So today we're going to introduce ourselves to alkanes and alkenes, which are basically two different families of hydrocarbons. Now, before we get into their details, I do want you guys to know what homologous series are, because alkanes and alkenes are two different homologous series. And what homologous series basically means is that they are two different families. So a family of organic compounds. Now, basically what this means is that if, for example, a compound meets a certain set of characteristics, then it belongs to the homologous series of alkanes, which means that it belongs to the family of alkanes. Now, there are characteristics or points that you need to write for homologous series, and you might also be asked to define homologous series in your theory exam. And if for example, two compounds belong to the same homologous series, then they will have the same general formula, which I will explain in a minute. They will have similar chemical properties, so all alkanes will have similar chemical properties when compared to each other. And they will have an increasing trend in physical properties. So as you go down the list that I will give you, your melting point and boiling point will increase. So let's look at alkanes first. Now, we're going to start off, I'm going to give you the list of alkanes first, then we will go into their detail. So we have methane, we have ethane, we have propane, and we have butane. And I will not write after this, because then is after butane is just pentane, hexane, heptane, octane, which is something that most of us already know. The prefixes for number 5, 6, 7, 8, pentane, hexane, heptane, octane. Now, do you need to memorize the compound? No, you don't, because of the general formula. An alkane general formula is CH2N plus 2. N is the number of carbons, So the first compound in the list is obviously going to be the one with 1 carbon. So put it in the formula. You get CH4. Then you go on to the second one, C2H, put it into the formula. And so on and so forth. Do you need to memorize the names? Yes, you need to know that the carbon with 1 atom is methane, and with 2 is ethane, with 3 it's propane, and with 4 it's butane. But I assure you it does not take a long time to memorize, and it is not hard to memorize. Now, these are called molecular formulas, but you also need to know the structural formulas. What that means is you need to know how to draw this compound. So how are you going to do that? Well, first of all, you're going to draw the number of carbon atoms that are in the compound. So there are 2 carbon atoms. Then you're going to draw a single bond between, by the way, I'm doing ethane. I am drawing ethane. After that, you need to surround your carbon atom with hydrogen. Now, what you need to know, and this is very important, each carbon atom can only have 4 bonds. So you already have 1 bond over here, which means that you only need to add 3 more bonds to this carbon atom so it's satisfied. I need to add 3 more bonds to this one so this carbon atom is satisfied. And each of them have 4 total. 1, 2, 3, 4 satisfied over here. 1, 2, 3, 4 satisfied over here. And if you count this, well, if you count the number of carbons, 1, 2, C2, 1, 2, 3, 4, 5, 6, H6. So yeah, you ended up drawing ethane. Let's try propane. You're going to draw the number of carbon atoms, and there's going to be a single bond between each of them because this is an alkane. Alkanes have single bonds. Then you're going to surround each carbon atom with hydrogen while making sure that the maximum bond surrounding your carbon atom is 4. So you already have 1 here, 1, 2, 3. Then over this carbon atom already has 2 satisfied because of this one and this one. So you're going to add only 2 over here, and this one needs 3 more to be satisfied. And this is how you do an alkane. Now, alkenes. Obviously, now the prefixes are the same. However, because an alkane ends in ane, your alkene is going to end in ent. So there is the difference between an alkane and an alkene is that an alkene has a double bond. It has 1 double bond, which is very important because this is the major distinction between the 2 families. Now, there is no methane because methane represents represents a compound with a single carbon atom, and that's not possible in alkenes because you need a double bond present. That is necessary. So basically, you need this exact thing present at least once in the compound. Therefore, methane doesn't exist. We start off with ethene. So C2H4, ethene. C3H6, propene. And C4H8, butene. And pentene, hexane, heptane, so on and so forth. They usually do not go past 4 anyways. Now, I'm sure you guys can deduce that the general formula for alkene is C2H4. Is CnH2n. And once again, is the number of carbon atoms. So let's start off with, 2. Put it in the formula. C2H4, you got your ethene. Now let's try to draw it. Once again, you're going to draw the number of carbons that you have. So let's start off with ethene. We have 2. You're going to draw a double bond between them because it's an alkene. Now remember, each carbon atom can only have 4. Since you already have 2 here, you're only going to add 2 more. 2 plus 2 is 4, right? This is how you ensure that your carbon is satisfied. So this carbon is satisfied. Over here, you need to add 2 more. And so This is ethene. Now let's try propene. Once again, you're going to draw the number of carbon atoms that you have. Then you will put a double bond between two of them because you need to have this existing in your compound. You can put it here, you can put it here, it doesn't really make a difference. So I'm going to put it here. There we go. And then a single bond here. Now, once again, 2 already over here, so you're going to have only 2 here. Now, this carbon atom is satisfied up to 3 already. It has 2 from here and it has 1 here, which means that you're only going to add 1 more to this one. And then this one needs 3 more to be satisfied. And this is propene. And when you count them, 1, 2, 3, 4, 5, 6, it's the same thing. Let's try butene. Draw the number of carbon atoms that you have. Draw a double bond between 2 of them, single bond in the rest. 2 over here, 1 over here, 1, 2, 3, 4, because you can only have 4 maximum. 2 over here, because initially we only had 2 satisfying this specific carbon atom, and 3 over here. And then you just put in H. Now, one other way that you can differentiate between an alkane and an alkene is by using bromine water. So this is called the bromine water test. And if you need to identify if the unknown substance that you have is an alkane or an alkene, you will add bromine water to it and it decolorizes in alkenes. So bromine water has kind of like an orange, red, brownish color. And if you put it in alkene or if you add alkene to it, then it's going to become colorless. But if you add alkane to it, there is no effect on bromine water by alkane. So you will know, okay, it's not decolorizing, so this is an alkane substance. One other thing that you guys need to know is alkenes are called unsaturated compounds because of the double bond. So they are called unsaturated compounds. Very important. They might ask you this in your MCQs maybe. And alkanes are called saturated compounds. Last piece of information really quickly. Alkenes are more reactive than alkanes because the double bond is obviously stronger than the single bond. So alkenes are more reactive than alkanes. So yeah, this is a basic introduction to organic chemistry. In the next video, we're going to go into greater detail to on the reactions that alkanes undergo and the reactions that alkenes undergo. But I hope you guys understood what we've covered so far. And I hope you guys are able to draw the structural formulas because that's very important. Okay, until next time.